Hello everyone, welcome to my YouTube channel Easy Way to Learn. I am SHAILJA and today's topic of discussion is isomerism in carbon compounds. So let's get started, remain focused and follow the lecture. See, isomerism means existence of different organic compounds having same molecular formula but different structural arrangement or having different structure is called isomerism. So those compounds which have same molecular formula but the arrangement of atoms is different. That is isomerism. The phenomenon or the property exhibited is called isomerism. And the compounds, organic compounds having same molecular formula but different structures will be called isomers. This will become more clear with the example. Let's take, for example, butane. So this definition can be understood with the help of organic compound butane. By now you must be knowing how to write the formula C4H10. See, this is a 4-carbon compound butane. See, if we write the carbon skeleton, I am just writing the carbon skeleton. Means just carbon-carbon bonds. See, and let's number it. Number it here. 1, 2, 3 and 4. See, this arrangement is called a straight chain. A straight chain. And there is one more possibility that it can also arrange in this manner. So now the long chain has been reduced. So 1, 2, 3. We number the longest chain. So here the longest chain is 3 carbon and 1 carbon is attached to the carbon number 2. So this is called branched chain. Branched chain. So butane can arrange itself in a straight chain and also in a branch chain. So these two arrangements will give rise to two different compounds, both having this formula C4H10, but their arrangement will be different. So this will be called isomer number 1, you can number it, and isomer number 2. So butane exhibits or butane has two isomeric forms, and you can fill the rest of the bonds with hydrogen atom. See? So this is butane and this one is 2-methyl butane. How we are going to name it? I'll explain it in a while. You take a screenshot of this. See, in case of butane, there are two isomers possible, straight chain and branch chain. See, in a straight chain, if we number the carbon atoms, so we get 4 carbon atoms in continuous series or continuous chain. And here we get 3 carbon atoms in continuous chain. So when branching happens, the continuous chain of carbon is reduced or it is shortened. Okay. Now let's fill the remaining bonds with hydrogen. So this is 1 carbon atom with 3 hydrogen. It is represented here as CH3. Then CH2, CH2, then again CH3. So you can write it in this form or this form. Both the forms are correct and you can represent it in any way. So, but it is better that first you write this skeletal network, then you write this formula. That will make things much easier. See, it will help you to write this form. Once you have practiced well, you can directly write this form. But initially you start with writing the skeletal form, just carbon-carbon joining. See, put remaining hydrogens in the compound. See. So let's name it. So the naming will be based on IUPAC nomenclature that we'll study in detail later on or in next video. But here I'll give a slight hint how you are going to write down the name. See, this is straight chain, so it is butane. You just write butane. And in this case, the naming will happen as follows. See, first you have to select the longest carbon chain. You can select it from anywhere. See, you can write it 1, 2, 3, 4 as written here, or you can select carbon chain from anywhere you want. See, 1, 2, 3. So you get continuous chain. So continuous chain doesn't mean that it should be in a straight line. It should be just continuous. Means it can be like this, it can happen like this, it can happen like this, but there should be just continuity. So this confusion most of the children face, that they assume that continuous carbon chain means that you have to look just a straight way. No, you can go either way. You are finding the longest chain, no matter what the shape is coming, it should be continuous. So the key word is continuity in the carbon chain. So if you are selecting carbon number 1 here, then see 1, 2, 3. What form you are getting? Something like this. So this is also a continuous chain. So don't get confused that you have to only select in just a straight line. No, it's not like that. So this is a very troublesome thing that children face across. Okay. So this continuous chain will give you the parent name. Parent name means like in this case, the name will be propane. Propane. And at 2 carbon atom, there is a group called methyl group. This is CH3 group called the methyl group. So you will write 2 dash methyl propane. So the name will have this, the last word suggests the number of carbon atoms in a continuous chain. This is called the parent name of the compound. And in this straight chain, we are getting one methyl group at carbon number 2. So that will be mentioned before, 2 dash methyl propane. And one thing you must note, that after the number there should be a dash. So dash will be in between number and the alphabet, and there should be no gap while you write the name. So it should be methyl propane with no gaps. And first, only the first alphabet will be capital. 2 methyl propane. So these are the few points you must notice while writing, that between the number and the alphabet there is a dash. You have to put a dash. The first alphabet should be capital, and there should be no gap while you are writing the name. That is, there should be no gap between methyl and propane. This last word tells the number of carbon atoms in the continuous chain. So here you see, in this compound you are getting methyl at 2 carbon atom here, and if we see this one, we get methyl at 2 carbon atom here. See, if you are not familiar with the alkyl groups, I'll just tell you here. See, in alkanes when you remove one hydrogen atom, you get alkyl series. So alkane with one carbon less will give you alkyl series. So see, if you have this methane, so remove one hydrogen, you will get methyl. See, at carbon number 2 you are getting methyl. This is not considered methyl because this is the part of continuous chain and this is the branching. And one more thing, that wherever branching will take place, the number of hydrogen will be reduced. See, here in carbon number 2 there are 2 hydrogen, while if branching occurs at carbon number 2, the number of hydrogen will be reduced. So here carbon number 2 is having just one hydrogen. So this is also one clue how to look for branching. Wherever you find the carbon number is reduced, and you can just find that point as a branching point. See, if you have alkane C2H6, that is ethane, this one is methane. By now you must be thorough with the name ethane. You remove one hydrogen, you get C2H5. So this is called ethyl. So this is one more series that you must remember. You studied alkane, alkenes, alkynes. Now these are alkyl. So this is how alkyl is formed. Removing one hydrogen from alkane will give you alkyl series. Hence we write 2-methyl propane. Okay, now we'll look at another compound, that is pentane. See, in case of pentane, we are getting 3 isomers. One is straight chain and 2 where branching is occurring. So in the second isomer, branching is occurring, and in the third isomer, it is much more branched. So as the branching increases, the straight chain shortens. See, I'll mark the straight chain. See, in case of a straight chain, you get 1, 2, 3, 4, 5. 5 carbon in a continuous series. Now when the branching occurs, you get 1, 2, 3, 4 carbon in continuous series. Okay, you can even start numbering from this carbon also. See, you can write it in this way also. Instead of beginning from here, you can write it 1, 2, 3, 4. This is also continuous chain. Okay. In this case, numbering can happen like this: 1, 2, 3, or you can number it from top to bottom: 1, 2, 3. That is also fine. So best is, let's select the straight one first. Here, 1, 2, 3, 4. So this is the carbon skeleton that we have drawn. So in case of branching, you assume that this fifth carbon atom, you break the bond and place it at carbon number 2. Okay. Here I'll remove one doubt also. See, if you place carbon here, so the numbering will change. You cannot number in this way: 1, 2, 3, 4. Because there is one more rule, that while numbering you should begin from the end so that the branched carbon gets the least number. So if you shift this carbon here, as I have done it here, so the numbering will also change. So numbering will begin from right to left. See, 1, 2, 3, 4. So simple rule is this: while numbering, from which end you will start, you will see that the branched carbon should get the least number. So either you are numbering from left to right or right to left. The branched carbon should get the least number, and this is the branched carbon. सो जहां पर भी ब्रांचिंग हो रही है उस कार्बन को आप सबसे छोटा नंबर दोगे। तो ये अपने से डिसाइड करना है कि हम नंबरिंग कहां से चालू करेंगे। तो अगर कार्बन को यहां प्लेस किया है तो नंबरिंग राइट से चालू कर दो, और अगर इस तरह नंबरिंग कर रहे हो तो लेफ्ट से चालू करना है। So this is one more rule you must follow while numbering the carbon chain. Okay. So fill the remaining bonds with hydrogen. See what you get: CH3, CH2, CH2, CH2 and CH3. 1, 2, 3, 4, 5. Here CH 2, 3. 1, 2, 3. So again you can write CH3, then CH, since branching has happened at carbon number 2, so number of hydrogens are reduced. CH, then CH3, then CH2 and CH3. So this carbon skeleton will help you to frame the exact formula. Then in this case, see CH3, CH3, CH3 and CH3. So it is C. Okay. Let's write the name for this one. So let's number it 1, 2, 3, 4. So 4 carbon compound, that means the parent name will be butane. So you can write butane. And before that, what you will write? 2-methyl. So methyl group is at carbon number 2. So you write 2-methyl butane. This will be the name for this second isomer. Again, here the naming will be, see, the parent name will be propane because the carbon chain has been reduced to 3 carbons. So propane. And at carbon number 2, you are having 2 methyl groups. See, one is here, one is up. So what you will write? 2, 2, then put a dash, dimethyl propane. I'll write it once again. So what this compound? It is 2, 2 dash dimethyl propane. Another thing that you must be careful, that between two numbers there should be a comma. So put a comma between two numbers, put a dash between a number and an alphabet. Then the first alphabet will be capital, followed by all the small alphabets and no gap in between. Or between dimethyl and propane there should be no gap, it should be continuous word. So these are the 3 isomers of pentane. So you take the screenshot. Let's see the structural isomers of hexane. So it has 5 structural isomers, and let's begin from here. See, this is a continuous straight chain compound, so its name will be hexane. Hexane. You can complete the rest of the bonds with hydrogen. So what you get? CH3, CH2, 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 then again CH2 and CH3. Let's count 1, 2, 3, 4, 5, 6. Yes. Here you will again complete it with hydrogen bonds, and see what you can do. You break one carbon, let's assume 6th carbon, and place it at 2 position. So what happened? This carbon chain is reduced to 5 because the 6th carbon is now attached to carbon number 2. So the name will be 2-methyl propane. So the parent name propane, not propane, pentane. 5 carbon chains, so it is 2-methyl pentane. Again, with the help of this carbon skeleton, you can write the formula CH3, CH, CH3, CH2, CH2, then CH3. 1, 2, 3, 4 and 5. So 2-methyl pentane. Now let's come to this structure. Again, here the methyl group is now placed at 6th position. You just shift this carbon from 2 to 3. So you get another new compound. So this will be, name will be 3-methyl pentane. 3-methyl pentane. Again, fill the remaining bonds with hydrogen. See, you get CH3, CH2, CH, CH3, CH2 and then CH3. See, the carbon where branching is taking place here and at this. See, the number of hydrogen atoms have been reduced. See, one hydrogen here, one hydrogen here. Now let's come to the 4th isomer. Here what you will do, break 2 carbon atoms from the chain and arrange them. So one form of arrangement is placing them at carbon number 2 and another at carbon number 3. So the name will be 2, 3, put a dash, dimethyl, then write the parent name that comes from the continuous carbon chain. So now the continuous carbon chain is butane. So write 2,3-dimethyl butane. Fill the remaining bonds with hydrogen. So the formula will be something like this: CH3, CH, then branched carbon CH3, CH, then branched carbon CH3, then CH3. See, the branching is taking place at carbon number 2 and 3 here. So both the carbons have reduced number of hydrogen. Now the next isomer. Again, these 2 carbons can be arranged in this form. That is, they can be placed on the same carbon atom at carbon number 2. So if you think you can place it here, so it will be the same compound. You won't get a new compound. See what I'm trying to tell you. 1, 2, 3, 4. So if you place these 2 carbon like this and follow this numbering 1, 2, 3, 4, you will feel that you get a new compound, but this numbering will be wrong, because you must remember that you will start numbering from the end such that the branch carbon gets the least number. So if you are writing in this way, so numbering will not begin from left end, it will begin from the right end. See, you will number from here 1, 2, 3, 4. So either you place both these 2 carbons on any of these middle carbons, किसी पर भी रखोगे, you get the same compound. तो इस पे अगर रख रहे हैं तो नंबरिंग ऐसे चलेगी, अगर इस दूसरे कार्बन पे शिफ्ट कर दिया तो नंबरिंग right? So both these compounds are same. See, at carbon number 2 you are getting branching, carbon number 2 you are getting branching. So ये प्रैक्टिस से आ जाता है करना, आप भी प्रैक्टिस करोगे तो आ जाएगा. See, put hydrogen atoms and now let's write the name. So it will be 2,2-dimethyl butane. See, 2,2 means that both the methyl are on the carbon number 2. So 2, 2, then put a dash, dimethyl because there are 2 methyl groups in the compound, butane, and the longest carbon chain is having 4 carbons. So this is the name. Now write the exact formula. See, CH3, C, CH3, CH3, then CH2, CH3. Since the branching has increased, so now this branched carbon is not having any hydrogen. So one thing you must notice that as the number of carbons are increasing, like we move from butane to pentane to hexane, the number of isomers also increase. In butane you get 2 isomers, then in pentane you get 3 isomers, and in hexane you get 5 isomers. See, butane has 2 isomers, pentane 3, and hexane 5 isomers. So here one thing is observable, that as the number of carbon atoms increase in a compound, the number of isomers also increase. See, butane is 4 carbon compound, pentane 5, and hexane 6. So as the number of carbon atoms are increasing, so the number of isomers are also increasing. See, no isomerism is possible in methane, ethane, propane, because they have 1, 2, and 3 carbon atoms, and there is only one structure is possible. So it is not possible to have different structures in them. So question is often asked, isomerism begins from which carbon atom or compound, or it begins with which carbon compound? So the answer will be butane, because methane, ethane, propane will have just one structure. Another important thing is that in addition to straight chain and branch chain, some carbon compounds also have ring arrangement. The carbons are arranged in the form of ring. An example is, 2 examples are mentioned in your book, cyclohexane and benzene. We'll see cyclohexane is a saturated compound and benzene is a unsaturated compound.